So this is nuclear chemistry, page 231, looking at the positron emission. So if you go and look on table N, we have a mistake here in the notes. You will see that carbon 14 does not go through a positron emission. So we need to make a correction. So if you go to your table N, and so on table N, and we're looking for positron, it has a symbol similar to the beta particle, but instead of a minus sign, it has a plus sign. And so you will see that the first example of a positron emission is calcium 37. So that should say 37. So calcium 37. So now we know the decay mode for the positron. So now go to your table O to look for the notation in the reaction. Okay? So when calcium 37, which is unstable, it emits a positron and its nucleus starts to fall apart, okay, the positron is what it spits out. And so we look on table O, we see that it uses an E like electron, a mass of 0, but instead of a -1 like the beta particle, it has an atomic number of +1. Once again, this is the bad stuff. This is the stuff, if you're overexposed to, that can do damage and make people sick. So once when the calcium 37 decays and it spits out and gets rid of this positron, we have to figure out what is the new, more stable atom that is formed. Well, we're going to use the same technique. The positron takes 0 mass with it, so the more stable structure has a mass of 37. Now, we are not given, but we need to look up on the PT. Calcium has an atomic number of 20. And look at the positron takes a +1 with it. So the new structure, whatever we assign it atomic number of, that number plus the +1 needs to equal 20. So if we assign an atomic number of 19, 19 plus a +1 will give us 20. So we see that the atomic number has changed, so that means we need a new symbol. So when you look on your PT, a nucleus with 19 protons is given the symbol K for potassium. Let's take a look at the summary of what happens from the unstable to the more stable atom that is formed during every positron emission. So we start off with an atomic number of 20 and we end with an atomic number of 19. So in every positron emission, the atomic number decreases by 1. The atomic number represents the number of protons, so therefore the number of protons in the nucleus also decreases by 1. Take a look at the unstable nucleus's mass and the new, more stable's mass. They are exactly the same, so the mass number doesn't change. So I'm going to write no change. Now we have to figure out what happens to neutrons. So let's just calculate. So mass minus protons will give us the number of neutrons. So 37 minus 20 gives us 17 neutrons in the calcium. And let's see, in the more stable, 37 minus the 19 will give us 18 neutrons. So in every positron emission, the neutron number will always increase by 1.